All right. Last time we've talked about the Boyle's Law. Just a quick recap about the Boyle's Law. Si Boyle's Law talks about the proportionality or the relationship between pressure and volume. And we learned that they are inversely proportional, meaning as we increase the pressure, the volume decreases, and vice versa. As we decrease the pressure, volume increases. So, yan. Our example of that was crushing a balloon. No? I don't know if that's the correct term because you cannot crush a balloon. Basta yung ginaganyan mo yung balloon. I leave that to your imagination. You are pressing the balloon. You are pressing the balloon. You are actually decreasing the volume and increasing the pressure as a result of that. We can actually always associate our lesson in life. Sometimes, your friends would try to ask you to do something. Like, your bad influence friend. Alam mo, try mo to, sige na, isang higup lang. No? Tapos, you will resist. And then, eventually, they would gang you up, no? Papaikutan ka nila hanggang liliit yung space around you, meaning increasing the pressure inside you. I don't know if that analogy helped, but that's the relationship of pressure and volume at constant temperature. Now, there was another scientist who realized another relationship between gas, 'di ba? Sana all may relationship. It was Charles, no? And this is our second law, no? The Charles law. I don't know if the apostrophe is here or lagyan natin ng ganyan. Charles says law. Some books, ganyan lang. Some books, meron pang S. And some book pronounce it as Charles law. Some pronounce it as Charles law. But different school, different pronouncement, right? Anyways, so si Charles law, he talks about the relationship between volume and temperature. Now, before I tell you the relationship between volume and temperature, I will leave it to your imagination first. Let's do some thought experiment na, like what would Einstein would usually do. Imagine you have a balloon in your hand, no? Tapos nilagay mo siya sa sablayan. Imagine mainit ngayon kahit medyo maulan-ulan. Nilagay mo siya sa sampayan sa tapat ng araw. No? What would be the volume? Would it be high or would it be low? For your imagination, probably you will think it would not change. Now, let's change the scenario. After putting the balloon outside in front of the sun, try to put it in your freezer. Yan, magpaalam mo na sa mama, baka pagalitan, baka sabi ano pinagagagawa. Pero if this is just a thought experiment, you'll realize that the balloon would shrink. Na-imagine? The balloon would shrink. Why is that? It's because, again, of the kinetic molecular theory of gases. Remember our first topic in the properties of gas? Kapag mainit, no, excited ang mga gas. They are moving very fast. Kapag malamig, no, they are moving very slow. They are affected by the temperature. Parang ikaw lang din, 'di ba? Kapag mainit, di ka mapakali sa bahay nyo, maglalakad-lakad ka, gagalaw-galawin mo yung damit mo. Yan. Kapag malamig naman, yan, nakaano ka lang, nakayakap ka lang sa sarili mo kasi wala kang kayakap. Malamig ang Pasko mo. So ano ka lang, naka-bend, yakap-yakap mo ang tuhod mo, tapos nakakumot. No? Gases and humans, no, behave in the same way. Halimbawa naman, yung mga wires sa tinampo, wires sa highway, kapag malamig, if you've noticed it, they are stretched. Diba? They are actually straight. No, kapag summer naman mainit, nakalaylay sila. No? They want to loosen up. So gases, humans, and other things behave similarly. So volume and temperature works in the same way like those that I have mentioned. So as we increase the temperature, so imagine a hot air balloon, that's the concept really behind it. That's their transportation way back in 1600s, I'm not sure, 1700s, when it was invented. As the temperature increase, the volume would also increase. If you decrease the temperature, meaning lumamig, the volume would decrease. So, as compared to our Boyle's law, the relationship of volume and temperature is direct. No, they are directly proportional. And to state their proportionality into an equation, that would be V over T is equals to a constant. Meaning, whatever you divide, if you divide the volume to the temperature, because since they are directly proportional, it would always be a constant. No? And if we place it in an equation to compare the initial volume and the final volume and temperature, initial and final temperature, that would be Vt, V over T, V1 over T1 is equals to V2 over T2. Alright, V1, T1 is equals to V2 over T2. Alright, so this is our Charles' law, no? The relationship of the volume and the temperature. Ano pa mga example before we proceed into the value-oriented examples? Pang mga examples ng kapag ininit mo, lumalaki yung volume with gases inside them. So maybe you can think of it. Halimbawa, ayan, we can also use the aerosol cans kapag nilalagay natin sa fire. You're actually increasing the temperature there. Therefore, the volume of gas, since they are moving very fast, they would try to expand. However, since the volume of that can is enclosed, meaning it's rigid, it's stable, it's fixed, no, it cannot expand, resulting to explosion. That's also the concept behind nuclear bombs, no, or hydrogen bomb in particular. Hydrogen is a gas, no. You increase the temperature inside, it would explode. Atomic bomb and even grenade. I'm not sure if inside the grenade, no, granada, gas siya. Pero if it's gas, it probably uses the same concept. I'm not expert in explosive, no. I am Sir Jello and I am not a terrorist. I am Kan and Char lang. If you get that reference. Anyways, let's put this into an actual example, no? The relationship of Charles' law. Say for instance, let's have another birthday celebration because we didn't have so much because of the pandemic. So it's your friend's birthday party. And you have at the room temperature, by the way, I forgot to tell you something. Now, when we talk about temperature, our unit should always be in Kelvin. Kelvin Klein. Kelvin Klein. Kelvin. You remember Kelvin? Because we've the normal unit for temperature we use is Celsius, but for the sake of the gas laws, we'll be using Kelvin. So if you've already forgot to convert Celsius to Kelvin, that would be degrees Celsius plus 273 Kelvin. So let's have an example. So hindi na birthday party, mahirap mag-imagine. Sabihin natin at 0 degrees Celsius, again, I'm not going to write the problem anymore, so I'll just dictate it. At 0 degrees Celsius, the volume of the balloon is 625 liters. And then suddenly, the management increased the temperature of the balloon, of the area of the balloon in particular, into 65 degrees Celsius. What would be the new volume of the balloon? So we are looking for the final volume. This is the V2. What would be it? So let's label first our values. Kasi alam naman natin ang nangyayari kapag walang label, di ba? V1, 625. Temperature, final is 65 degrees Celsius. And then initial temperature is 0 degrees Celsius. Now, there are quite a few things here before we move on to the actual equation and actual solution. First, we have to convert our unit for degrees, for temperature, because as I've just mentioned, we need to do it in Kelvin. So, the formula would be degrees Celsius plus 273. So, this will become, very good, that's 273 Kelvin. And this one, 65 plus 273, that would be 338 Kelvin. Very good, 338 Kelvin. So, that is your unit of measurement in its proper manner, not Kelvin and liters. Now, let's use the formula of Charles' law to find the volume. That would be V1 T1 is equals to V2 over T2. We are looking for V2. So, your basic math teacher would tell you what should we do first. So, let's do it step by step. We cross multiply. Now, meaning we use their multiplicative inverse. Now, that's the appropriate term. We multiply both sides by T1 and T2, if you can follow. Or, your teacher would just say, you cross multiply. Yun yung turo sa atin, diba? But that's the multiplicative inverse. V1, T2 is equals to T1, V2. Now, we have a linear equation. No? That's what we are very familiar. And then, to eliminate the threat, no, the company of V2, we remove it by dividing both sides by T1. Cancel, cancel. And there you have it. V2 is equals to V1, T2, T1. So, by the way, this is the skill you need to learn, no, in order to survive. No? Learn to manipulate the equations in order to find what you are looking for. So, this is our equation. Now, we simply input the values. V2 is equals to 625 liters. That's my V1. And then, 273 Kelvin over, mali. That's T2. So, that would be 338 in the numerator. 338 Kelvin. And on the denominator, that would be 273 Kelvin. So, Kelvin would cancel out and I'll be left with liter as my unit. Now, before you input that into your calculator, let me ask you. Now, kanina, ginamit natin si Charles' law to check. Now, we are going to use the Boyle's law rather to check. Now, we are going to use Charles' law to verify. Anong pinag-aiba nun? To be guided rather. So, if the relationship is true, that as we increase the temperature, the volume will increase, we are expecting a volume that is greater or lesser than 625. Very good. It should be greater than 625. So, we should get a volume that is greater than 625 because the temperature was increased. So, let's try to input these values in our calculator so that we can check if the Charles' law is actually correct. And by the way, of all the things that I've said and done, Charles' law only works if the pressure is constant and the number of moles of gas involved is constant. So, kanina, Boyle's law, temperature should be constant and N, or the number of moles, should be constant. Here in Charles' law, it is the pressure. No? Say for instance, at 1 atm. So, usually, may mga palito pa yan sa problem. No? At 1 atm atmosphere, the temperature blah 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 and the volume is blah blah. The temperature was increased. What is the new volume? So, don't be confused. Just learn try to understand what we are looking for. That's 625 times 338 divided by 273, and that would give us 773.8. So that's 774 liters. 774 liters of balloon, no, after we increased the temperature. All right. Now we followed through. The temperature increased, therefore the volume would increase. And there you have it, ladies and gentlemen, the Charles law or the Charles's law. Now it's time for you to do it. You don't do it to law. Charles law. So yeah, let's imagine a real thing. No, it's Peña Francia Festival 2021, and if you've noticed, they are using, or the Pepsi company usually donates a hot air balloon, which is often lighten up at around 5 p.m. no, in the same spots. I've memorized their spot already because we are there as early as 3 p.m. or 4 p.m. So the Pepsi company has started lighting their hot air balloon at a temperature of, say for instance, 35 degrees Celsius. And the initial volume of the V1, lagyan ko na para guided kayo. The initial volume at this temperature of the balloon is 500 liters. No, 505 liters. 505 liters. After some time, no, at a constant pressure, the volume was increased to 1,105 liters. What was the temperature during that time? Right? So use the example to use the formula for Charles law to solve this example. And kindly comment down your answer in the comment section below, because this is just a formative again. So just simply comment. Thank you so much. For the next meeting, for the next session, we'll be talking about Gay-Lussac's law, Avogadro's law, the combined gas law, and then the ideal gas equation. There you have it. Thank you so much and have a great day, mga ka-Chimek. Peace out.